Welcome to the DIY Honda Garage channel. DTC P0139 indicates a slow response from the secondary heated oxygen sensor, HO2S, also known as Sensor 2. In Honda vehicles, particularly the 2006 to 2011 Civic, the HO2S plays a critical role in reading the oxygen levels in the exhaust gases, allowing the engine control module, ECM, to adjust the air-fuel mixture accordingly for optimal performance and emissions control. Sensor 2 is typically located after the catalytic converter in the exhaust system, where it helps to measure the efficiency of the catalyst. A slow response from this sensor can lead to poor fuel economy, increased emissions, and may cause the vehicle to run poorly. When diagnosing this issue, it's essential to follow the proper troubleshooting procedures to isolate the cause of the problem, ensuring accurate repair and adherence to emission regulations. The primary function of the secondary HO2S, or Sensor 2, is to measure the remaining oxygen content in the exhaust gases post-catalytic converter. This sensor is crucial for determining how effectively the catalytic converter is functioning. It's located in the exhaust system, specifically downstream of the catalytic converter. When the system detects that the sensor is responding slowly, it triggers the DTC P0139, indicating a potential malfunction that could affect engine performance and emissions. The HO2S sends signals to the ECU regarding the efficiency of the exhaust after treatment. Thus, a fault could lead to increased emissions and poor fuel economy. Addressing this error is essential for ensuring that the vehicle runs efficiently and meets emission standards. This error code can arise from multiple issues. A faulty secondary HO2S itself is the most direct cause. It may be simply worn out or malfunctioning. Poor electrical connections between the sensor and the engine control module, ECM, can also result in slow readings from the sensor due to increased resistance or intermittent connection. Furthermore, discrepancies in the signals transmitted by the ECM, or even a malfunctioning ECM-PCM, could lead to improper readings, indirectly causing DTC P0139 to appear. It's crucial to investigate these potential causes thoroughly to ensure that the appropriate corrective action is taken to resolve the issue effectively. Drivers experiencing DTC P0139 may observe a range of symptoms indicative of a failing secondary HO2S. These can include noticeable decreases in fuel efficiency, as the air-fuel mixture becomes less optimal due to poor sensor readings. Furthermore, engine performance might become rough or erratic, as the ECM struggles to adjust parameters effectively. Increased emissions could also be a significant concern, likely prompting a check engine light and potential regulatory violations. A decline in drive quality not only impacts the enjoyment of driving, but can also result in higher operational costs for the vehicle owner. Therefore, early detection and resolution are pertinent to avoid escalation of these issues. The initial step involves turning the ignition switch to the on/I position. This step is crucial because it activates the vehicle's electrical systems, allowing diagnostic tools to access the vehicle's data. Before proceeding with further diagnostics, it's important to record all freeze data and any onboard snapshots, which provide critical information about the vehicle's status before the DTC appeared. Reviewing the general troubleshooting guidelines ensures that the technician follows the established protocols to prevent oversight of any crucial steps. This stage sets the foundation for accurate diagnostics and facilitates effective troubleshooting of DTC P0139. In this step, use the Honda Diagnostic System, HDS, to clear the DTC from the vehicle's memory. The HDS is an essential tool that allows for precise vehicle diagnostics, enabling users to reset any codes that may interfere with ongoing testing. Clearing the DTC also resets any onboard tests related to the sensor, which is vital for monitoring its behavior after the reset. It prepares the vehicle for subsequent diagnostic steps, including starting the engine under specified conditions later on. Ensuring the DTC has been cleared is critical for obtaining reliable data in the following diagnostic steps and effectively determining whether the issue persists. The next step is to start the engine and hold the engine speed at 3,000 RPM without any load, which means the automatic transmission should be in either park, P, or neutral N for automatic vehicles, while manual transmission vehicles should be in neutral. Maintaining this RPM is crucial as it allows the vehicle to reach operational parameters conducive for tests to measure the sensor's response. The goal is to hold the engine at this speed until the radiator fan activates, signaling the engine has reached an optimal operating temperature. This phase ensures that the engine systems are warmed up sufficiently, permitting accurate monitoring of the HO2S performance during subsequent tests. This step requires test driving the vehicle under specific conditions. Ensure that the engine coolant temperature, monitored by the engine coolant temperature sensor, ECT sensor 1, exceeds 158 degrees Fahrenheit, 70 degrees Celsius. This condition is essential as it confirms that the engine has warmed up sufficiently for the HO2S to perform optimally. The vehicle must be driven while in drive, D, for automatic transmissions, or in fourth gear for manual transmissions, maintaining a speed of at least 35 miles per hour, 56 kilometers per hour, for a minimum of 14 seconds. This will generate a stable environment to monitor the sensor's response and evaluate its function under various driving conditions. Crucial for troubleshooting the DTC P0139 effectively. After completing the test drive, the next action is to monitor the onboard diagnostics, OBD, status using the HDS. It is essential to check if the DTC P0139 is indicated on the screen and whether it shows as failed or passed. If the status indicates passed, it implies that the system is functioning correctly at this time, suggesting that there may be poor connections or loose terminals requiring inspection. If the screen indicates failed, it necessitates further steps, including possible sensor replacement or electrical diagnostics, to understand the underlying cause of the signal degradation. This monitoring is critical to determine the immediate state of the vehicle's emission control system and its reliability. In this step, turn the ignition switch to the lock 0 position to safely power down the vehicle's systems before proceeding. If the OBD status indicates failed, investigation of the secondary HO2S and its electrical connections is required next. Poor connections or loose terminals at the sensor or the ECM can lead to failures in sensor performance. If any such issues are identified, correcting them should take precedence to restore normal operation. If after correcting, the issue persists, this prepares the technician to replace the secondary HO2S sensor as the next logical step in resolving DTC P0139 effectively. The seventh step involves replacing the secondary HO2S sensor. It's crucial to ensure that the replacement sensor is the correct type designed for the Honda Civic 2006 to 2011 to maintain compatibility. Proper installation techniques must be followed, ensuring that seals are intact to prevent any exhaust leaks that could skew the sensor's readings. Once the new sensor is installed, it's vital to double-check all electrical connections to confirm they are secure and free from corrosion or damage. A proper installation can play a significant role in ensuring the sensor performs within operating parameters, helping to clear any faults displayed by the HDS and restore vehicle emissions performance. With the new secondary HO2S installed, turn the ignition switch to the on position again. At this point, it is critical to reset the engine control module / powertrain control module ECM PCM using the HDS, which helps clear old data and allows the newly installed sensor to initialize correctly within the system. This reset ensures the ECM can recalibrate and adapt to the new sensor, avoiding conflicts with previously stored data. Subsequently, prepare to perform the idle learn procedure, which is a step that allows the ECM to understand the new idle characteristics of the engine, optimizing performance right from the start after the sensor replacement. The ninth troubleshooting step requires performing the ECM-KeyCM idle learn procedure. This procedure is essential because it allows the control module to adapt to the vehicle's new baseline conditions, particularly after replacing critical sensors. Start the engine and let it idle without load as before, ensuring the automatic transmission is set in Park, T, or Neutral, N for automatic vehicles. The goal is to maintain this idle state until the radiator fan turns on, which exemplifies that the engine is within proper operating temperatures. This learn procedure is integral for the ECM to accurately adjust fuel management and ignition settings, thereby enhancing overall engine performance and emission control going forward. In this penultimate step, conduct another test drive under the previously specified conditions to ensure the new sensor is functioning correctly. As before, ensure that the engine coolant temperature, monitored by ECT Sensor 1, exceeds 158 degrees Fahrenheit, 70 degrees Celsius, to validate that the engine has reached optimal operating conditions. Also, maintain a vehicle speed of at least 35 miles per hour, 56 kilometers per hour, for a minimum duration of 14 seconds. This helps simulate real-world driving scenarios where the sensor needs to respond accurately. Observing the sensor's data during this drive can confirm whether the issue has been resolved and whether DTC P0139 is still present or has cleared. After completing the test drive, check for any pending or confirmed DTCs using the HDS. If DTC P0139 is indicated, it requires further investigation of the vehicle's wiring and connections at both the secondary HO2S sensor and the engine control module, ECM. Conducting visual and voltage tests can help ascertain the integrity of these connections. An indication of failed suggests that the problem persists and the installation or calibration may need additional work. Conversely, if no DTCs, including P0139, are indicated, it signifies that repairs likely resolved the issue, paving the way for the next step in verification. Lastly, check the onboard diagnostics, OBD, status via the HDS again. Determine whether the screen indicates passed or failed for DTC P0139. A passed indication signifies successful repairs, suggesting that the secondary HO2S is functioning correctly and the vehicle's emission system is restored. This confirmation is key to demonstrating compliance with emissions regulations and ensuring vehicle performance is optimal. However, should the screen indicate failed, once again, further diagnosis of wiring and connections must occur. Similar to previous steps, validating that all components interact correctly without interruptions. Upon completing all troubleshooting steps, it's vital to confirm that the repairs have indeed resolved the DTC P0139 issue. Verify there are no additional DTCs present, indicating the overall health of the vehicle's emission system. This ensures that the secondary HO2S sensor is not only functioning correctly, but also has been integrated well into the ECU's operational parameters. Review all connections one last time for any manner of issues like corrosion or looseness, as these can often result in repetitive failures. A successful verification confirms the effectiveness of the troubleshooting process, ensuring that the vehicle can operate efficiently and ecologically. To prevent recurrence of the DTC P0139 or similar issues, implementing a regular maintenance routine is essential. This includes periodic inspections of the secondary sensor and other related components, ensuring any signs of wear or malfunction can be detected early. Furthermore, the integrity of the entire exhaust system is vital. Ensuring no leaks or physical damage can go a long way in preserving sensor function. Additionally, it's crucial to monitor the wiring and electrical connections associated with the sensor and the ECM. Proactively addressing any identified electrical issues can significantly reduce the risk of sensor failures, leading to better vehicle reliability and performance. In conclusion, DTC P0139 signifies a slow response from the secondary HO2S, a crucial component for maintaining optimal engine performance and emissions control. Following a structured troubleshooting protocol is essential for accurately diagnosing and rectifying the issue. This includes testing, monitoring, and potentially replacing faulty components, ensuring that everything from physical connections to electronic signals is functioning correctly. Regular preventive maintenance practices can significantly mitigate the risk of future issues while promoting long-term vehicle health. Understanding and addressing this DTC is instrumental in fostering both engine efficiency and compliance with emission standards. Please like and subscribe to the channel. See you next time.